everyone, welcome to the next session on ANSYS CFD tutorials. In this session, we will analyze the NACA 4412 airfoil for an angle of attack of minus 20 degree. We will see how the airfoil stalls in the air at this angle of attack. We will start by double clicking on Fluid Flow Fluent. Next, I'll go to Geometry and right click. New Design Modeler Geometry. First, we'll go to Units, Millimeter, XY plane, look at. I'll go to the option of points. It is asking for the coordinate file, which I will give, and then click on Generate. Next, I'll go to Concept 3D Curve. Here I'll change it to Point Selection, and then I'll click on Then I'll select the points one by one. Once this is done, I'll click on Apply and Generate. You can see here the sketch has been made, but the 2 points are left. So I'll go to Concept, Lines from Points, and I'll select both the points by pressing the Control button. Then I'll click on Apply and Generate. Then I'll go to Concept, Surfaces from Edges. I'll select both the edges, Apply and Generate. Then I'll click on this point such that these points disappear. Then I'll click on Look At. I'll go to XY plane, Sketching, and choose Line option. I'll draw a bounding box here. Then I'll go to Modify and choose Trim option and remove the extra lines. I'll give the dimension to these lines. H1 is 200. This is 50. L4 is also 50. P2 is 100. Then I'll go to Concept, Surfaces from Sketches. I'll select the sketch 1 which I just created. I'll click on Apply and Generate. Then I'll go to Create, Body Transformation, Rotate. Body is this airfoil which I'll select from here. Axis is the XY plane. And angle is minus 20 degree. And Generate. You can still see the line body. So I'll go to the line body, right click, Suppress Body. Then I'll go to Create Boolean. I want to subtract from this main body the tool body which is the airfoil and Generate. So now you can see this is the geometry. Now we'll close this window. We'll go to Mesh and double click. I'll go to Mesh and change the default sizing to 0.001 meter and Generate. Once the meshing is done, I will give name to this side, create name selection as the inlet. This side is the outlet. This is the airfoil. And these two are the wall. So you can see here all of them have been labeled. Now I'll go to Mesh and Update. You will get a message over here saying that the mesh translation to Fluent was successful. Once this is done, you can close this window. Then we'll go to Setup and double click. I'll select double precision, solver processes 2 and start. Here first we'll go to models. The viscous model which I'm going to choose is the SST-K omega itself. You can change it as per your requirement. Material by default fluid is air, so I don't have to change this. I'll go to boundary conditions, inlet velocity. I'll give this value as 15 meters per second. Apply, close. Then I'll go to reference values and double click. Here I'll compute from the inlet. Reference zone is a surface body. Then I'll go to methods. Here the turbulent kinetic energy model is a second order upwind type. Then I'll go to monitors, report plots. I'll click on new and new again. Force report, drag. The first one is the drag coefficient. So I'll write here drag space CD on the airfoil. Print to console. OK. Again I'll click on new. Force report, drag. Drag force. So I'll write here drag space force. I'll select the airfoil. Print to console. OK. Then I'll click on new again. Force report, lift. Lift coefficient, I'll write here lift space CL. I'll click on the airfoil, print to console, OK. Lastly, new force report, lift. I'll choose lift force. So I'll write here lift space force. I'll select the airfoil, print to console, OK. Click on OK and close. Then I'll go to initialization. Here hybrid initialization is what I'm going to choose. So I'll select initialize. Once the initialization is done, I'll go to calculation activities, autosave every iteration. I'll give number of iterations as 20. OK. Then I'll go to run calculations and double click. Number of iterations I'll give as 250. Calculate. So the calculation is complete. I'll click on OK. You can see here this is the drag coefficient. Highest value is 0.1856. The drag force value is 25.57 Newton. The lift coefficient CL is here you can see minus 0.43. And here the value is minus 59.5274 Newton. So once you've got these values, you can close this window. OK. We'll go to results and double click. We'll first go to streamline. OK. We'll start from symmetry 1. Number of points I'll say 80. OK. So you can see here the velocity is 0 and there is separation and also there will be some vortex creation. This is the wake region. So all of these can be seen over here. The airfoil has got stalled actually in the air. The highest velocity is 31.55 meters per second over here and in this zone. You can go to animation and see this result. You can select streamline 1, type is sweep animation, remove the forever loop and you can just play this and see. If you want, you can change the size of this ball to 0.6. OK. And then you can play this by reducing the speed a bit. So initially the air flows over the aerofoil, but the rest of it keeps moving in this zone because this is where the vortex has been created. Once you're done with the streamline, you can go to contour. The first contour is of pressure. Location is symmetry 1. Range is local. Number of points, say we give us 110. In render, we'll remove the show contour lines and click on apply. So now you can see that in this zone, the pressure is lower over here. It is minus 1.197 into 10 raised to 2 Pascal. In this zone, it is higher. It is 5.234 into 10 raised to 2 Pascal. Next, we will create the second contour of velocity. So it is about the symmetry 1. Here we'll choose velocity. Range is local. Number of contour points is 110. I'll go to render and remove the show contour lines. Click on apply. Now you can see that in this zone there is complete separation of the fluid. As you can see, the fluid is flowing in this way. Here the velocity is completely zero. There is turbulence and hence stalling of the airfoil. The highest velocity is in this zone and over here, once it has passed over the airfoil. So what you see over here is the stalling of the airfoil at 20 degrees, which is above the critical value of angle of attack, which can be chosen, that is 15 degrees. So with this, I end the session. I hope you have understood the analysis. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.